As with single population hypothesis testing, we can also solve a problem for two population means when we do not have the population standard deviations. We will demonstrate this both with interval testing and hypothesis testing. When we don't know the population standard deviations, we will use the sample standard deviations and we will replace the Z statistic with the T statistic. The challenge here is to determine the degrees of freedom to use for the T statistic. Well, this second formula looks complicated. It only has 4 input variables, the 2 sample sizes and the 2 sample standard deviations. Our interval estimate, as you can see, the margin of error will be the T statistic times that standard error of the 2 population means. Let's go through an example with 2 different car models where fuel economy is important. Here's the data for the samples for the 2 different cars. We have the sample size, the sample means, and the sample standard deviations. We will develop a 90% confidence interval for the difference between the 2 population means using the 2 sample means. First, we determine the point estimate for the difference between the 2 population means. We will take the difference between the 2 sample means and we get 2.5 miles per gallon. Using that ugly formula for the degrees of freedom, we get 24 degrees of freedom for the T statistic. Using the T distribution table for alpha over 2 of 0.05 and 24 degrees of freedom, we get a critical T value of 1.711. In calculating that margin of error, we get 1.069. Therefore, the miles per gallon difference between the 2 populations will be between 1.431 and 3.569 with 90% confidence. We can follow the same procedure for hypothesis testing, and the pattern for the null and alternative hypotheses are the same for the 1- and 2-tailed tests. And our T statistic, our test statistic, is shown here. The difference between the 2 sample means minus our hypothesized difference between the 2 population means divided by the standard error of the mean. Using the same example with the 2 car models in miles per gallon and a 0.05 level of significance, we're trying to prove that the mean for the M cars, population 1, is greater than that for population 2. So we restate that as the alternative hypothesis, mu1 minus mu2 is greater than 0. The null hypothesis then is the opposite of that. At the significance level of 0.05, we calculate our test statistic to be 4.003. Given our degrees of freedom of 41, we will use that to find the p-value. Our test statistic of 4.003 is greater than a t-value for 0.005. Therefore, we know that our p-value is less than 0.005. Because this p-value is less than our significance level, we reject the null hypothesis. Therefore, we are at least 95% confident that the miles per gallon performance of the first car is greater than the miles per gallon performance of the second car. Similarly with the critical value approach, at 41 degrees of freedom and an alpha of 0.05, we get a critical t-value of 1.683. And we know now that we can reject the null hypothesis because our test t-value of 4 is greater than 1.683.